Hello, and welcome to this video that is going to talk about the discriminant as it relates to quadratic functions. Okay, so I'm going to give you the definition, then we're going to do a little exploration on Geometry Sketchpad, uh, take a couple of notes on what the discriminant means, and then do a few problems where you're applying just some basic principles. I don't think this is too hard. You shouldn't be too scared. Um, Rigorous questions could be added to this topic later, but this is a pretty straightforward notion that we'll address here in this video. So, okay, so the discriminant, what is it? Definition. It is the value under the radical in the quadratic formula. Okay, so if you notice I have the quadratic formula here. So the value under the radical is simply b squared minus 4ac. This is in fact the discriminant. The discriminant is a number that you get by computing this value, b squared minus 4ac. Also, the value under the radical is also known as the radicand. Anytime you have a radical, specifically in the quadratic formula, the radicand is called the discriminant. Its use, and you'll see that as we go here, is to count real zeros, also known as roots, also known as x-intercepts, for quadratic functions or equations. Okay? So if it's a function, you would be able to have a graph and see its x-intercept. Okay? Again, zeros are x values that make an output of 0. Similarly for roots, that's why these are all kind of related and synonymous. So if we said that the discriminant is a value, that value could be greater than 0, equal to 0, or less than 0. And there are no other options for that. Basically, you're saying it could be positive, it could be 0, or it could be negative. Okay? So let's take a look over here at this Sketchpad demo and explore that a little bit. Okay? I've got your basic quadratic function here with these sliders that allow me to manipulate it. Okay? A, B, and C value, right? Given in the idea of this standard form for the function f at x, also known as y equals ax squared plus bx plus c. Okay, so just a couple of things to note here. I've got the quadratic formula rewritten with the word discriminant underneath the radical. Okay, and then here in this one, it is computing the value for the given slider values. Also up here in this table, if you see, I'm trying to talk about the value of b squared minus 4ac, okay, as well as the roots for this function. If you notice, root 1 and root 2 here are 0. The root is, again, the x-intercept. And we see here just in this most basic example that the x-intercept here is 0. And there's only one of them. Okay. So this table's cool. When I double-click it, it actually takes the value that I'm currently looking at here, okay, and kind of grabs it up for storage. So now let's take a look here. If I just animate the sliders, the points for a second, and I'll stop it here for a second, we see that the discriminant is a negative number here. B squared minus 4ac is negative 2.6, and because there are no x-intercepts, the table says both roots are undefined, which means don't exist. I'm going to animate here again. I'll stop here. We see that we have b squared minus 4ac here is 30, which is a positive value. And I have two roots. Okay? And then we could animate the sliders again, or I can manipulate them myself, which I will this time. And you see here that, again, I've got the discriminant of 7.8, which is positive, and I get two roots there. I'll kind of just randomly animate again. And we'll see here that we have a discriminant value which is negative, which is giving me undefined values for the roots. And here I'll do some actually by hand manipulation. Again, I wanted to pick one where you can see that A is negative here. The discriminant is still negative. A was positive in the last one, and the discriminant was negative. But again, it's not so much the values of A, B, and C as it is the value of B squared minus 4AC. Okay, so let me give you a couple of other looks at this. We see here that the discriminant is 0, and I get one root. You're like, well, there's two roots in the table, but if you see that they're both -2, it's really one root. Okay, and I'll take another value here, and we see here the roots are the same. Even though the parabola opens up, the discriminant is still 0. I'm getting the same roots. And then we'll see here again, the discriminant is 0. I've got two roots again that are the same, which is really one root. Okay, so what does this mean? Okay, what does it mean? Let me just get a little bit of a look here at this table, and we'll put it over here with the notes. Okay, copy that, come back here, get rid of this, go for quick paste. Okay, now, if you notice here, I'll do a little highlighting and erasing. B squared minus 4AC is greater than 0. Well, that would be here, here, and we see that when we have these two examples of discriminant values that are greater than 0 or positive, you in fact get two roots in both those instances. Okay, so just take that out for a second and say that we are in fact going to get two real roots. Okay, now we'll look here for where it's equal to 0, which would be here, 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 here. Okay, we notice that you are in fact getting one root. It's the same root both times. Okay, so when the discriminant is 0, you're in fact getting one real root. Okay, do a little erasing here of these table values, and then we'll look here and say, well, when the discriminant is negative, which was here, here, and here, you see that you don't get any root values. You don't get any x-intercepts. You don't get any inputs that make the output 0. So you get 0 real roots, okay? And as an aside, you'll learn this later, but it means you get two imaginary roots, okay? And if we think about that, it's because, well, we're saying that the radicand is negative. Just erase a little bit here, get rid of these values. These will become sort of some very useful notes for you in the form of this table that we just made. But we're saying here, if you take a look at this number, b squared minus 4ac, which is underneath the square root symbol, when that's negative, you're going to get the square root of a negative, which is going to result in an imaginary number. Okay? Now, again, if this number were 0, the square root of 0 is 0. So when you do plus or minus 0, you're really doing the same thing twice. Plus 0 and minus 0 are the same thing. So you're really only getting one root. And then when this value here, the discriminant's positive, the square root of a positive is another positive number. And then you're going to do plus that positive and minus that positive. Well, that gets you two distinct answers. That's why you're getting two real roots. Okay? So I hope that sort of is enough exploration. It's hard sometimes to do exploration when you're talking about a video here. It's passive and not so interactive, but I tried to demonstrate this as best I could. So now let's take a look here at a couple examples. I won't do all of them. I'm just going to do a couple here. Determine the number of zeros for the quadratic functions, equations, or functions below. Don't find the solutions, just say the number of solutions. So I'm going to do 1 and 3 here, and then I've got something on the next slide that we'll look at. Okay, so if we see here, it's 1x squared, that's our a value. B is -5, and C is -7. So I've got b squared minus 4ac is the formula I'll use, which is going to give me, try and go in color here a little bit. Okay, we're going to get -5 squared minus 4 times 1 times -7, which in fact is going to give me 25 minus 28 is -3, excuse me, plus 28, which is 53, which is greater than 0, and this means you'll get two real solutions for that equation. Don't know what they are just yet. I'm just trying to classify them, okay, and do some observation of what to expect. Okay, so now if I look at 3 here, I've got A is 25, B is -60, and C is 36. So again, if I were to use this formula, I would be getting -60 squared minus 4 times 25 times 36. Well, 60 squared is like 6 squared with 2 zeros, so that's just going to give me 3,600. And then I see here, negative times positive is minus. 4 times 25 is 100. 36 of those is negative 3,600. So I get 36 minus 3,600, which is equal to 0. Okay? So when the discriminant is 0, you get one real solution. Can't say what it is. It's not that the solution is 0. You just know that there's one of them. Okay? Just a quick look here on the next slide. We're going to apply this a little bit more. Not all teachers ask to do this. Just starting to be thoughtful of a couple of different ideas that you put together. It says use the notion of A, which is the A value of A, B, and C. A is the coefficient of the quadratic term. So use the notion of A and the discriminant to make a very rough sketch. Okay, and I'll make the very rough sketch of these graphs, and you'll see what I mean by very rough. Okay, so what we have here, again, if we're looking at b squared minus 4ac, I want to look at the a value because it's set in the direction to do that. A is 1, so a is greater than 0. So just like you remember from transformations, we're going to get a parabola that opens up. We know it's a parabola because it's a quadratic. Okay. And then I'll take a look at b squared minus 4ac, which is going to give me 1 squared minus 4 times 1 times -3. Okay? Which is going to give me 1 plus 12 is 13, which is greater than 0. So I've got two real solutions. Okay? So combining these two real solutions with understanding that the graph is that shape, my very rough sketch here is just going to say, if this was the x-axis, I'm in fact going to get an upward opening parabola that has two real roots. So I should see a sketch where there's two intersections. Similarly, if I look here, I'll use this formula again, b squared minus 4ac. I'll make a little statement on a. But first, we need to get a little better writing here. Say y equals -2x squared plus 0x minus 4. So now you can see that I've got a is -2, b is 0, and c is -4. Remember, b is always the coefficient of the linear term. The linear term is the term that is the variable of x, not x squared. So here we go. We've got 0 squared minus 4 times -2 times -4, which is going to give me 0, and then 3 negatives multiplied together is a negative. We've got 32, which is -32, which is less than 0, so it's no real solutions, which means no x-intercepts. We also want to go back here, and I missed it in the chart, but you should be able to be flexible enough. A is equal to -2. Therefore, because it's negative, it's a reflected parabola, so it is flipped over. And when I'm looking at that, we're going to see that I've got here, if this were the x-axis, I would in fact get an upside down parabola that does not intersect the x-axis. Now, I don't know any points on it. I just know where it is in relationship to the axis, if it's intersecting it or not where, and which direction the parabola opens up. So, I hope this was valuable to you. The discriminant is something that, like we said, its only function is to count the number of real zeros for quadratic functions or equations. And when you're counting them, your only options are to get 2 real roots, 1 real root, or 0 real roots. So, hope this was useful to you. You'll see the notion of counting roots in pre-calculus as we elaborate past quadratics. So hopefully this will start to give you some thought about that.